Well, howdy. Today we will be learning how to use the timeline. A long overdue tutorial that I should have incorporated into my classes. And also the subject will be bolt design. So it's important to start with a sketch. I'm going to use the ground plane to begin my sketch. And I'm going to start with a couple of concentric circles. The first one will be 20 millimeters. And let's zoom just a little bit. Second one will be 10 millimeters. And again, to try to make sure that my circles are concentric, I am using the origin as my center point. Very important that those circles are concentric. I'm going to extrude now both of these at the same time to make a solid cylinder 5 millimeters high. All right. Now, at the bottom here, I need to turn this sketch back on using the eyeball right there to toggle the visibility. And I'd like to extrude my shaft 25 millimeters in the negative. Make sure I'm using a join operation over here in the dialog box. Okay. And at this point in time, we're ready to go ahead and start talking about applying some threads. So from the Create pull-down menu, I am going to apply thread right there. And I'm using the ISO metric profile. In this case, I set it up to be a 10 millimeter size. And I also want to check to remember size if I'm doing tapping and dyeing for quite a few different parts. Checking that box to remember the size will ensure that none of them are mismatched. Also need to make sure that it is modeled. So I will check that box and you'll notice a difference right away. I'll uncheck it so you can see. If I am not modeled, it literally is just placing an image of some threads over the shaft. If I model it, it does go ahead and cut away the material. All right. I'm going to say okay to that. And at this point in time, let's zoom back in on the bottom. And I want to go ahead and work on this sketch again and create a polygon. I'm intentionally skipping a step. I would normally fillet the top of that bolt, but I'm going to show you how to use the timeline and get that in the correct order. So I want to use an inscribed polygon. I already know the value of my inscribed polygon should be 20 millimeter diameter, so that means I can just literally click on the edge there. And we are ready to extrude to remove material. And we will ensure that this extrusion performs a cut operation. Okay, as you can see right here, it is removing material with the cut operation. All right. And of course it's turning red, which that's the sign that the material will be removed. I'm going to say okay to that. Extrusion. All right. Now, let's talk about some of the common mistakes. As I mentioned earlier, if I don't fillet the top of this bolt first before cutting away that material, then I am going to have a very undesirable looking fillet, and I'll show you a rule fillet, all edges on this surface, 2 millimeters. Okay. Now that might seem like I did the right thing, but it is wrong. That is not what bolts look like. That is not how bolts are made. Okay. In fact, as I was mentioning earlier, they should have had the fillet applied before the hex cut away the material. So I'm going to go ahead and delete. I'm using the timeline down here in the lower left-hand corner. I'm going to go ahead and delete that feature. All right. And what I want to do instead is I want to drag back on my timeline, roll back some of this history to here. Okay. Right after I extruded that shaft, or even one step before that. Okay. What I want to do instead is I want to go in and I want to fillet, instead of a rule fillet, just want to apply it to this edge right here, and I want it to be 2 millimeters. Okay. Now when I roll this history back, I can't really tell how it's going to affect everything, but when I roll it forward, I can clearly see now that is the way the bolt is supposed to be filleted. If you look at any bolt head, it would match this configuration. All right. So in the timeline, you can correct if you got it out of order of operation. But the correct order of operation is as soon as you make that first cylinder for the bolt head, you go ahead and fillet the top of it. Now let's talk about what do I have to do if I noticed another problem. Well, let's zoom in on the bottom of this. In a lot of cases, there's supposed to be a chamfer there, a 1 millimeter chamfer. We need to roll that back on the timeline because this bolt does not look correct, and I will show you how to correct that. I just rolled back the history on the threads only, and I'm going to go into chamfer, and I'm going to add the chamfer, just a 1 millimeter chamfer right there. Okay. Let's have a look at how that affects this final view. Much better. That is much more in line, more realistic with what a finished bolt product would look like. Okay. What else? Well, let's say that we determined that this should not be a full length. It was only supposed to be 20 millimeters of thread. Again, we can edit any feature on the timeline by right-clicking on it. All right. If I right-click on that feature, I can go back in and I could even change the thread pattern or other class, direction, but we don't need to do that. We just need to change the full length to an actual length of 20 millimeters. Okay. And then once again, you'll notice what we have is much more realistic looking. In some cases, you don't need a full-length thread pattern. All right. So that is a completed bolt. Well, let's go ahead, turn off the origin, and we'll render this sucker so that we have exactly the type of bolt that we want. In this case, we're going to go to the physical material, and let's say stainless steel. That's a very expensive bolt if we make it out of stainless, but it would endure the elements for many, many years beyond a regular steel bolt. So we're going to be looking for steel, go through stainless, and I want the ANSI 309 stainless. So I'm going to drag and drop that onto the bolt. All right. And we'll check and see. Yes, the ANSI stainless has been applied. We can, at that point in time, go back to design and save our work. From the design menu, save. And you can see a color change already now that we moved from the plain steel to the stainless steel. It is a brighter, shinier metal. Well, ladies and gentlemen, hope you enjoyed the timeline lesson and hope it helped you design better bolts in the future.